Okay.
Yeah, it was. Check. So, good morning, everyone, and thanks for coming to this tech talk. And let me welcome Mr. Brian. He has been working for, I think one of you have to sort of stop his speaker as well. Right? Only the mic people can not the whole. Is it now echoing? No, it's better. So, Brian has been working. Yeah, Brent has been working for Apple specifically in security area for about 8 years from some of their flagship products like iPhone to iPad to various and being a known tech lead in the area of security. And then he moved to video processing, surprising from there to here.
Yeah.
That is in Smith, right? And then he became an entrepreneur. As classic Silicon Valley career path, and been working in various endeavors, and also invested in multiple companies, and recently reached out to me, looking to see like how the landscape of Sri Lanka is evolving in terms of tech resources, and so that he wants to sort of engage with us in terms of tech jobs. And he already working in the data science and ML area in various parts of the region, and look for talents, look for opportunities and help. So I thought he'll be like a good resource for you guys to sort of learn from, as well as to engage with, to learn your progression as well. Brian, this is the majority of it here are like our final students.
Okay.
Some of them have specialization in data science and AI. Some of them are from cybersecurity. Some of them are from classic computer science. So those are the major fields, and also integrated computers. So we have 4 major streams.
Oh wow!
So one is like more like embedded and IoT. Other one is data security. The other one is the data science. Then the other one is the classic computer science. So the 4 streams we have. The final students are here. They are currently engaging in their final project, which is more like a research project for a year they will conduct, and they will eventually, most of them publish in a reputed conference. And we also have a postgraduate students in that, about 10 of them right now. And we have another set of like people who are joined online as well. So that's they are here, and as you know that. Entrepreneurial culture is slow, but it's still happening thing now in Sri Lanka. And some of their seniors, like in CS, like we have been like now witnessing final year students creating startups from their projects. In fact, we already have one of our students picked the course and started, which I don't recommend, but still, just to give you an idea, like we have the culture slowly emerging here, and given that given the constraints we have. It's this kind of momentum is I think is something you may want to know.
Yeah, no, which is very good. Yeah.
And thanks for your time, and happy to have you. So over to you. And you can click this if you want.
Okay. Thank you. Thanks, Subhaya, for the introduction. So let me tell you a little bit about what they already did, but just a little bit of my background. I grew up here in Sri Lanka. I was born in Sri Lanka. I went to Royal, and then I think I left here when I was 24 or something like that. Right. So I really enjoyed, being here, and also it was the early days of computers. So we did a lot of programming, and when I was a student, I ended up writing software, and we used to sell software to some of the big Sri Lankan companies. Yeah. Oh, it's not sharing? Oh, sorry. Yeah, you can go share. You can. Yeah, it's fine. Yeah. You can probably enable the Zoom right there. enable the sound. Yeah, yeah. You can share. Okay. Great, perfect. Yeah. And then it's been my one of my biggest passions was in computer science, the early days, and working on algorithms, right? Because algorithms were very exciting. My favorite course was the data structures and algorithms, and then eventually I began to really love operating systems. So when I graduated, it was, I mean, I got a job in Sri Lanka here, but then for a while, for a couple of months, but then I got interested in working on operating systems because I was working pretty important areas. And then I ended up doing cryptography and security and working for Apple, worked on the first iPhone, did a lot of projects and did venture capital, right? Invested in companies. I sold a company to Smith Micro in 2010. So I went through the entrepreneurial journey, and now I'm with this. I've co-founded my next company called Iterate Studio, which is an AI platform, right? So we basically, the reason I'm showing you some of these examples is to kind of show you how AI can, what you are really learning can be applied in the industry, right? It's not just something that you are learning that will go to waste, because it's very powerful and the world needs it, right? I don't know if you guys know this, in America, the market for AI, that means companies that would total size of market companies that would buy AI software is almost around 1.1 trillion US dollars. That's how big the market is for companies buying AI software. So AI is growing really, really rapidly. And in fact, that prediction, the IDC, the firm that actually does these predictions, changed their number 3 times. Initially, they said the market is 300 billion. And then a couple of months later, they said, the market is growing faster than our prediction. Got to 600, and then they fix it again. And then the last couple of weeks was 1.1 trillion. Right? So we are looking at a big need among large companies. So there are a lot of AI use cases. So today, my today's talk is going to focus on AI use cases, and towards the very end, we'll get a little bit more technical, right? Because I wanted to show the applicability and the use cases and why AI is used in the industry in a powerful way. Even just our company alone, I mean, we have 102 people and we've deployed AI solutions at 2,108 locations, right? So if you imagine you're pumping petrol, like you're pumping petrol, you go to the petrol station and you put your credit card onto a Uber type app, and automatically the cameras will identify your license plate and open up the pump, right? Because like, in toll booths and all, like in China and US, when you drive your car fast, the toll booth, the camera will identify you. But that happens, doesn't happen immediately. There's a batch process. In a petrol station case, the moment you are being identified, you have to open the pump within 30 seconds. Because in America, people are, they're not patient, right? Everyone's in a hurry, so the pump doesn't open up, they will use the service. Right? So we built a very fast system that will do that. And it deploys across both countries in the US. In 4,100 locations, right? The other application that you see there, right in the middle, the second one, is when your car gets into an accident. You basically take out your cell phone, open your app, and then moving around the accident. You will use computer vision to identify what the damage is. So we went through about, I think 100,000 or, like prior damage file and $20 stuff. And then it goes through 20 million prior damage fixing, records. So it identifies how much will it take to fix the damage, and it'll actually give you a quote, by insurance company how to fix it, right? So that's a very real practical example. Like all the stuff we're studying, it's being used in a very day-to-day basis. And at the very end, you have that thing where the document, we work with a lot of banks here in Asia. I mean, we don't sell our software directly to Asia. We work through Fujifilm, they are our partner. But in the US, we work with a lot of banks. But even in Asia, we have customers like UOB and a lot of banks who use our software. Right? But this is the reason I'm showing you all these things is that the data is very powerful. Its use cases are everywhere. And when you guys graduate, and you will eventually be working with solutions like this, right? These are some of our large customers that in India, America, and then in Europe as well, right? And then over the 2 to 3 years, we grew really fast, right? So when you start a startup company, when you as an entrepreneur, you don't know where to go. You have a vision, you have a dream. But then when you want to think about in building a company, you want to focus on getting and identifying the right use cases and to be able to provide value very quickly to customers, right? So if you can have revenue, then the company can grow. You can hire more and more people, right? So revenue is the key, right? Which is what you wanted to look at, right? We are about 102 people. The other thing that's really interesting is that because AI is growing so fast, even companies who are leading in the AI space, like NVIDIA, Google, AWS, all these guys are like they're all competing really hard on AI, right? Especially with generative AI. What has happened now is that the NVIDIA is leading because it takes a lot more to train these generative AI models, right? Because transformers are very intense computing. So companies like Intel and others are struggling because of the way the world is moving fast. But they are also trying to combat the problem by providing, if you look at any generative AI transformer model, there is a training and there is the inference, like prediction, right? But with the training, you can do very costly GPU, and the inference you can do on a very cheap CPU. Right? So companies like Intel will play in that space. Yeah, because what happens today when you're deploying AI solution, AI is still expensive for retailers and regular traditional companies, right? How do you look at a given sentence and figure out where the attention in that sentence is, right? And that changes the world, right? Because if you look at like in the world of AI, once in a while you will get one big innovation that would just basically change everything, right? So in the because a lot of times when I tell senior people and people who've already been in the industry that I'm in the AI space, they always tell me like, well, I studied AI in 1975, right? And I say, which is actually true. AI was there in the 70s, right? But then what happened is that but that AI was very statistical oriented AI, right? And then somewhere in the 2008, 2009 timeframe, right? Jeff Dean and a bunch of people they started inventing backpropagation, right? The technique to balance the neural network. The moment backpropagation got invented, boom, AI took over, deep learning took over, right? So that's why in AI, what happens is you need kind of like the three critical elements to kind of come together, right? You need to have billions and billions of data that needs to come together. And then you need to have like amazing hardware to power AI, because without AI is very hardware and resource intensive. And then you need to have great algorithms, right? A lot of people, if you read like news articles and when in CNN or whatever, they talk about AI, they said, well, NVIDIA is building the greatest hardware. It's great they're building great hardware. It's not just the hardware. It's the algorithms that run inside the hardware that make the breakthrough, right? You may have the great hardware, but then you are just brute forcing, right? Some of you guys are security people, right? So it's like a brute force attack. With hardware, with better hardware, you can brute force better and do more brute forcing, right? But if you have amazing algorithms, you don't need to brute force, you can cut through things, right? So one of the things that happened in 2017, 18 timeframe is we came up with a transformer, right? Transformer is the ability to process language, right? With various attention layers and so on. And that allowed you to build generative AI solutions much, much faster. And so then you had ChatGPT and all these guys, one after the other. The revolution began, right? Another thing that sort of that kind of changed the world is basically GANs, right? Adversarial networks, right? The generative adversarial networks. The thing about GANs is that's another way where it's another contributor to where generative AI is today, because it allows you to basically mimic a lot of human behaviors, right? You guys know how GANs work, right? You have a discriminator in there, right? And then basically the generator will begin to generate the images, and then till the delta becomes closer, it will continue to do the generation, right? So these are the things that created the revolution, right? Because a lot of times when you are in computer science, you know the truth. You know that everybody, the media will talk about, well, it's great hardware, we have lots of data and great hardware will always be there because that's Moore's law, right? But what's not going to be there is great algorithms. So as your computer science folks who are working on, software, think about great algorithms, because algorithms can change everything, right? Even today in the generative AI world, right? There are lots of problems, and I'll talk about, where you can think about inventing, right, towards the end. Right. So this is what I was talking about. That we went through three eras or three evolutions. There is statistical and machine learning systems, which is where all of our dads and grandpas learned, right? The statistical method. Then there is deep learning, which started in 2009 to 2016, 17. It's still there. We're using it. And then you have large language models with transformers, right? So you cannot think about it like three eras, right? So now the question is, where is generative AI being used, right? So generative AI is being the use cases in all kinds of areas. I mean, that's one of the reasons this is a big revolution, because using generative AI, if you take a company, the company has, external things where customers are interacting. Let's say like you go to McDonald's, McDonald's has an app, and that app is an app the customer is interacting with, right? But then if you go into the McDonald's company in the back office, they are processing a lot of data, some data analysis looking at payments or whatever. So that's all back office, right? So generative AI, what's really beautiful about generative AI is it's one of those technologies that can work both for your customers in the very front, right? And it can work for your employees in the very back. So that's why you see like, it can change every department. You can use generative AI for human resources. Imagine in the future, like when you post a job, right? And there are already systems in Silicon Valley where, software startups, where you can actually put their software in. You just simply say, I need an engineer with machine learning thing. It'll generate like 20 profiles for you. Like, is this the type of profile you want? You pick the profile. It'll automatically basically send out the profiles to LinkedIn. And then when you won't know what the profile is. So you'll just simply see like this company wants to hire with this profile, and it's all machine generated. The HR didn't type it, right? And then you say apply, and then it'll automatically put out a quiz. So you, in an AI quiz, and you're an ML, or you say you're getting hired like a Python engineer, it'll generate a Python quiz for you. And then you fill everything and AI will actually correct it, right? And then it'll basically find the top 5 candidates and set up interviews with the HR and the hiring manager. So AI can work in an end-to-end fashion, right? Same thing in data management. Every area AI is playing a big role, and especially generative AI is going to be very powerful, right? This is another view, right? Previously, I showed you an organizational view. Now this is an industry view. So that means insurance companies, financial services companies, like the stuff that I showed you, like, you take a phone and you take a picture, like, and it'll tell you what the damage is. And that's for the insurance company, right? Healthcare, right? All the X-ray analysis, everything. Manufacturing, right? In fact, we're working with companies where we're using cameras to look at the assembly of a circuit board, right? Like if you are in an airplane, the Wi-Fi that comes in the airplane, that's actually a specialized board that's manufactured, that one side it has satellite connections and the other side it has Wi-Fi, right? But manufacturing of that Wi-Fi is done by one of our partners, but then AI systems can actually look on top of it at the 12th step, make sure the screws are loose or like whatever is tight properly, the bezels are correct. That's all done through AI, right? Security, as you know, threat detection, threat analysis, anomaly detection, that's all machine learning, right? Marketing, human resources, so the examples are across every industry, right? Earlier, all these things were built using various machine learning systems. Nowadays, with generative AI, all of those stuff is slowly going to go into an LLM. So one LLM or a couple of LLMs, large language models, can do a lot of different things for you, right? So the world is changing fast, right? So this is an interesting timeline, right? Because the thing with large language models, and as we learned before, as we looked at before with generative AI, you need lots and lots and lots of data. So if you have lots and lots of data, you also have to do lots and lots of training. You need to have a lot of GPU, right? So as you know, GPU is expensive, right? In the university, you may get GPU free, but if you were to pay for the GPU in your company, it's very expensive, right? I think T5, monthly cost for T5 is probably at $3,000 a month. If you get an A100, the one that most of these models are trained, is probably like 20K or something, right? And if you get an A100 80 gigabytes, it's probably the same price. So what I mean to say is, because of the cost, it took millions of dollars to train earlier ChatGPT 3, right? 175 billion parameters, but it took them millions and millions of dollars to train it, right? But over time, as you see those red dots, you see everything in red, that's all open source, right? So whenever you have open source in the AI world or in the generative AI world, in the LLM world, it's actually very good. You know why? Because open source democratizes, right, code, and you always want open source to be there. And that's a happy news there. But over time, as you saw, open source pretty much overcame some of the existing models. And in fact, Meta, Facebook now, right? They have, now Meta, but early Facebook, they have released a model called Llama, right? They have Llama 2, which actually is completely open source. You can download it and build it in your machine, right? So you can even run it without a GPU, right? So it's really beautiful to see that technology is getting democratized, right? Even Microsoft has recently said they are going to abandon parts of ChatGPT and they're going to use Llama 2 because it's cheaper, easier to run things like this, right? So that's an interesting revolution that you are seeing, right? Same thing on the image side, right? The same thing on the image side, right? And you guys have you guys heard of stable diffusion? You know what stable diffusion is? You can go into stable diffusion and basically say, generate me a man walking on moon, and it'll generate an image for you. It's an image generator, right? So originally it was open AI came up with DALL-E, but very quickly you started, you saw open models coming up. So open source is taking over, which is great, which is good for students like you, because you can take things and you can begin to modify them and use them in a more useful manner, right? So this is just some examples, right? Like, that organizations can use generative AI, in pumping fuel, in drive-through scenarios, product upselling, car washes, and so on. So anywhere you need a human interaction, you can put a machine in there that would basically bring down your cost and also could do interactions more effectively. So the challenge with like drive-throughs. Do they have drive-throughs in Sri Lanka now? No, right? Like that's my. There are few, right? Okay. 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 There are few in Colombo City. Okay. In the US, there is every every corner you have a drive-through, right? It's very common. So typically a drive-through scenario, there will be about 3 to 4 agents or associates working in the store. But then when they get crowded, the cars queue up, right? And it's always a problem because in the US, it's all about speed. So now we are actually experimenting generative AI capabilities using drive-through, right? So you can order your whole burger using an LLM. In the back, it's not a human, it's an LLM, right? I'll actually show you some demos in there, right? Same thing in banking. I'll show you some banking example, and I'll just run through a series of use cases, right? So this is a scenario where you drive your vehicle to a drive-through and you have all the burgers there, right? And then you can pick your burger and you can have a conversation with the machine. It'll sound very human, and then you can even change your order, do everything. In fact, I did a demo at a big conference recently where, I demoed the drive-through, but in the background in my phone, I played a voice of a little baby crying, because that's a real life, right? Now you're going in your car, your wife's next to you, the baby's in the back, she's crying, the loud voice. But how do you, with all the ambient voice, how can you actually respond in a drive-through, right? So we did a lot of work in that space to make sure that the sound works better and all that stuff, right? So I'll do a quick demo. I hope it works here. That's it. So this is an example, right? Okay. It's like going somewhere. So let me do this. But if I turn on, I need to hear from, because this thing will talk back to me. Okay. Okay. All right. Let me start regarding. Okay. I'm actually going to play a full interactive session. Yeah, I'm going to interact with this thing.
Bill's Burgers. I'm Bill. What would you like to order today?
Can I get a traditional Bill's burger, please?
Sure. Would you like a traditional Bill's Burger or a traditional Bill's Burger combo?
Get me a combo, please.
Coming right up. Your traditional Bill's Burger combo includes a traditional Bill's Burger, medium fries, and a 20 ounces drink. The total price is $8.99. Would you like anything else with that?
Can you get a chocolate milkshake for my child, please?
Certainly. Adding a chocolate lover's shake, regular, to your order. The price is $2.79. The updated total for your order is $11.78. Is there anything else I can get for you today?
That'll be all. Thank you. Right. So I'm talking real time to an LLM, right? So that's very powerful, because generative AI could, 4 years ago or 3 years ago, we couldn't do that, even with a regular chatbot, right? Because you need to have understanding of language, right? So this is a really powerful use case of an LLM. Right. Okay, great. Okay. This is another example of an application we did for a bank here in Asia, right? So one of the challenges is that they don't have withdrawal fees in Singapore, but they have ATM withdrawal fees in other countries. So you basically have, instead of building a regular chatbot with NLP, you are building a chatbot fully run by LLM, right? The challenge in a scenario like that is what happens with LLMs, as you know, in generative AI, is that LLMs have a habit of hallucinating, right? So LLMs in America, we have this joke, LLMs are like a teenager. They will give you an answer whether they know it or not. Right? So it's very hard to control. It's very hard to control hallucination, right? So we did a lot of training trying to control the hallucination in an LLM. Right? So one way is that this is a big problem. This is a big research problem. How to make the LLM not hallucinate, right? So there are ways of where you can tell the system.
Recording in progress.
Oh, sorry. Okay. There are ways to tell the system. That's a concept of system prompt. It's basically the main control to the LLM. Do this, don't do that. Like for example, for that burger application at Generative, we basically told when somebody comes and talks about politics, just simply say, I don't know. Right? Because it has information about politics, it may give you a view. So you gotta be careful with this, right? Because, and then suddenly the company will have billions of dollars worth of lawsuits, you know. Somebody will be upset and they'll sue the company, right? So you have to control the LLM, right? So one of the things is, of course, editing the system prompt, like I said. So we did the editing the system prompt.
Recording
here. And in fact,
stopped.
some of the Sri Lankan colleagues here. Okay, so some of the Sri Lankan colleagues here help us to build it, right? So one of the ways we got around it is basically, if you take a large LLM, it's very hard to control a large LLM, right? But small LLMs, T5 Japan and so on, with less parameters, you can control them better. So you can, there is a process of cleaning up of the data, it's actually called history. So we ended up doing history to have made the LLM always tell what we want, right? Because these are all learnings, right? Because this is so new, a lot of these LLM and generative AI is so new, we ourselves are learning, right? So one of the things we do at Generative is we have a drag and drop platform. All those components are abstracted. So we take a lot of AI components, voice components, and put them into little Lego blocks. So you can take the Lego blocks and drag and drop it, right? Because a lot of the machine learning stuff is very reusable, right? Because it's very reusable, you can sort of take advantage of the connectivity. Right. Another interesting application or use case for generative AI is forecasting, right? Because forecasting, what happens is, like, this was a real example. We were working with a convenience store, it's like a gas station, type company, right? One of the problems is that during winter, they would suddenly have this crazy uplift of coffee cups because everybody wants to drink coffee and everyone's just coming into the gas station to buy coffee. But then the regular forecast data didn't have it. But then what we did was we had data that the LLM did have data about people's training from some prior training. And it actually was able to pull that and kind of correlate the data and say, during winter months, we have this uplift, right? So that kind of interesting capabilities are coming from an LLM, right? The other thing that we have also been doing lately is in big databases, right? In companies, they have lots and lots of databases. So if you're working in IT, you know, your CEO might come to your CMO or your marketing or somebody and say, you know, tell me the average order value will change in product. How did it change? How did conversion change in that product, right? And the CMO will call the CIO, and then CIO will call somebody in IT and say, hey, find me this information from this track. But a lot of times what happens, there will be like 20 different databases. You need to go and put this information, do a join query, take that data, come to another database, and 2 days later, the IT guy will give a nice report, like a PDF file, right? That's the whole way of doing things. But with LLMs, you can actually connect all the databases into an LLM, and you can give the LLM to the CMO, right? And you can actually ask English queries, and LLM will translate those things back, right? So there are these really, this is the data. So people like Microsoft and like us, a lot of different companies are playing hard in this space because there is this is a big use case in terms of data analysis for large companies, right? This is another interesting case that I'm going to talk to you about, right? For banks, when you apply for a loan, right? So you typically apply in a paper or whatever, the data goes into the bank, and then if you just apply on the online system, it will go into your database. That system will basically pick it up. And then if you have this paper, then the digital copy will get OCR, and the OCR data will all come into textual tabular data, and then LLM can begin to analyze. and it can generate loan documents for you, right? I'll actually show you a demo of that application as well. So this is a classic example, right? So if you are in the financial business, you would actually have a let's call it a pre-feed and a post-feed analysis when you apply for a loan. It's actually called pre-feed, so all the loan applications. And then you are looking at this person's financial status, right? Is this person for a given month spending more? Or does he have one-time large spending, or does he have ongoing spending? So based on all that factors, your loan percentage, your interest percentage, and your denial, approval or denial can happen, right? So this is an example where all the documents are coming in. I mean, of course, this is bank, so we had to take out people's names, but then it's all fake names, right? Then you see all their spending habits, right? This is their daily spending. And then here, if you look at it, automatically that spending goes into an LLM, and the LLM is basically telling right now for this given person, right? For this given person, there is one potential red flag. That is total outflow is more than the total inflow. That means he's spending more money than what's coming in, right? In the given month, right? And then it's also looking at its current bill style, and it's saying, and then the other thing is in the bank world, what typically do is like the banks have all these rules. Right? If you spend $50 to $50 in a gym, and the name gym name, whatever the gym name, they go out there, so this is the finance, this is the gym exercise. You're spending for exercise. You go to Keys or Cargills and Sorry. Yeah. If you go to Keels or Cargills and buy that they know it's grocery, right? But the beautiful thing about LLM is an LLM will know what Keels is. You don't need to code what Keels is. You don't need to categorize Keels as grocery. It knows Keels is grocery because it's looking at billions of data already, right? So like this report we generated directly from somebody's financial statement without any training. The LLM just did it as is, right? That's why I think this is powerful, because now you are, and then based on the condition, it will actually generate you a loan document. So this is a real powerful use case of using generative AI, right? So I'm just going through practical industry use cases, so you will understand how the industry is using a lot of these things, right? This is another interesting case we have been using. Our software is being used by a lot of banks to do document OCR identification. So when a document comes in, there is OCR. You guys know what OCR is, right? Object character recognition. So you read a physical document, and then the ML system would basically extract the pixels and whatever and find out what characters are there, and then it'll basically convert the characters into textual data, right? It sounds very simple, but it's actually sometimes very hard and very complicated, because if you look at bank documents, there are tables. There'll be a big table there. Like if you look at a bank statement, a headers at the very top, there'll be a table. There'll be a table inside a table. Sometimes there'll be like multiple rows that don't match to the other row. And then these are scanned documents. So somebody would have put a paper clip in, right in the column data, there'll be like a hole in there. So you don't know what the heck that is, right? So you have all these problems with documents. So earlier, we have a big, really powerful OCR system that was built in our platform that's being used by banks. But lately, one of the things we've been trying to do is train an LLM, right? Because with the OCR system is you need to train the OCR system how the document template is. How exactly all the things are like templated, because every bank statement is templated in a particular way. So with the LLM, you can actually avoid that. So we actually took a multimodal LLM called Donut, it's open source, and we trained Donut to start actually recognizing documents. So in our next future versions, we'll actually put Donut in to automatically do it, right? So what's really interesting in this case is not only can you build new use cases using LLM, but you can take your old use cases that you've done through traditional deep learning, and you can retrofit them, right? You can refit them with LLMs. right? So this is another retrofitting example, right? As I showed you previously that we have 4,000 instances of license plate recognition across 12 countries in Europe and in the US, all powered by our software.
பழைய
But
project
all
license
that stuff
plate
was done by
recognition,
deep learning,
OCR எல்லாம்.
deep learning computer. Lately, what we did was we went back and said, okay, that's great. Can we use an LLM for it, right? So we basically trained the same donut across all the license plates we knew, right? So it basically took that's my license plate. So then it's taking my car and it's actually recognizing the license plate, right? So but what we did was that we ran this through two separate systems. On your left, you actually have a CPU run. So that means we ran this LLM on a CPU, right? But it's very slow. It takes 1.9 seconds to recognize the license plate, right? Our deep learning software, our previous deep learning system can recognize a license plate within 10 milliseconds, right? Worst case scenario up to 30 milliseconds, right? Because that's how fast, that's the patience that consumers have, right? You go into the shop and you park your car and bam, the pump should open. If the pump doesn't open, then they won't use your system, right? So, but with LLM, we are still not ready because the computing power is still very high. So you cannot run this in CPU, right? But on the other side, if you look at it, we ran it on a TPU. You guys know what TPU is? It's Google's tensor processing unit. It's like a GPU, but built by Google, right? So in Google Cloud, you can actually, if you're a Google Cloud user, you can get a TPU, right? So we ran it on a TPU, and a TPU gave the thing much better, 0.6934, right? So the reason I'm showing you is eventually in the next year or the year after, this number, this 0.6934 or this 1.94 seconds, maybe like 0.002 seconds. Maybe it'll become 10 milliseconds, right? That's the world we are living in. That's how fast it's getting optimized. When that happens, now I don't need to write a deep learning computer vision application. I can just train an LLM and put it in front of me. So the AI will penetrate the world a lot faster, right, than we think, right? It's a matter of time. I mean, this was done, I think, 4 months ago because it's cutting edge. I have a lot of engineers. We have about, I think right now, 20 some engineers in Sri Lanka, and we have the US Silicon Valley engineers as well, right? Between them, we have an AI team about 45 people, right? But this is some of the stuff that our engineers did, like, I think 4 months ago. If we do it today, this numbers might be much better. It's changing like that every day, right? Right. So this is another example. We in fact did this with an Indian company, right? This was like basically the use case was, they were a mattress company. So then, they had cameras in front of their mattresses. So if you go in front of the camera, it will basically tell you, if you use of a mattress, you will sleep like a baby, and it'll give you a younger version of your face, right? So this is not a generative AI case, but it was too slow. We did this with a cascaded deep learning model, right? A DNN, a deep learning neural network, right? So that's my face in the middle. And then that's a younger version of me. The beginning is my face, and then that's a younger version of me. It's still, I think, the machine learning systems still have biases. It's not very good with darker faces, right? It does a better job with Angelina Jolie, right? When you need whiter faces, it does because most of these systems are trained with Caucasian faces, right? That's another computer science problem that a lot of people are trying to tackle. How do you take systems and train them for Asian, and African and various populations, right? So this actually on this side is a younger face, and that side is kind of the older face. But that's all like deep learning neural networks are doing this. Okay? This is another interesting thing. I can show you some demos here. So one of the things about this one is there is a company that we work with in America. They're a cookware, right? So they sell these sophisticated pots and pans, very expensive pots, pans, and stuff like that for home, right? So one of the things their marketing team wanted to do was, you don't just simply sell the pots and pans on the website. What you do is you actually sell recipes, right? How do I make this chicken biryani? How do I make this chicken soup, right? So what we did was we trained all their pots and pans into a generative AI, and then we gave it a recipe and told us, go make this chicken curry with their pots and pans. And that's what it did on that side, right? It's a chicken broth or something. Yeah. And American food is not that tasty. So, it's not, you guys will look at this and say, this is like bad food. but But the idea is that it's using the pots and pans of, you know, of the of the company, right? So that's a generative AI, real powerful use case, right? I think I have it somewhere. Let me see if I can show it to you. Okay, I'll find it. I'll find it and I'll show it to you soon. Okay. Another example. This is another really powerful example. Okay, I have like 12 minutes. Okay, this is another powerful example where you go to a retailer's website. It's basic, and you're looking at jackets. And assuming as you're a loyalty member, your photo is uploaded. It can automatically fit you on that jacket. So this is one of our ML leads, Shamron, and that Shamron uploaded his face, and generative AI automatically fit him in the jacket. So it's personalization, right? You're personalizing content for you using generative AI, right? So this is another very, very powerful case, right? This is another similar case where, our designer, Brandon, he got retrofitted in a suede jacket. It's from Men's Warehouse, right? So all those things can be done in a very powerful way with generative AI. This is another interesting case, right? This is because we have, it's kind of funny because our company have customers who are all the way in like really like gas stations and all kinds of stuff. And on the other side, we have customers who are in beauty. So Chanel is a customer, Ulta Beauty is a customer, Elf is a customer. So we actually have like a lot of male engineers who actually know a lot about makeup, because they have to work on all these things, right? So this was one of the things we did in the beauty space. So this is a beauty product. It's a skin cream by Jennifer Aniston. It's called Lola V, right? Actually, at the bottom, you can see her face. So what she's selling her product through this company called Ulta. They're not in the US. Think of them like a Sephora. They're a Sephora company, right? They're larger than Sephora in America, right? So what happens is they're selling the product on their website. And there in the middle right there is the description of the product, right? So typically in a big company in marketing, there would be a person called a merchandiser, right? Merchandiser is the person who writes about the description of the product. So the merchandiser wrote that product about that description about Lola V. We said, why don't we give it to the computer to write it in the actual voice of Jennifer Aniston, right? The LLM already knows Jennifer Aniston's voice because it's probably passed all the movie tracks and she knows how she speaks, right? So what it did was we went and wrote in her voice. It says, listen, life's a journey, right? And your hair should enjoy the ride too. That's where Lola V's Restore product travel kit comes in. This little package is a jet setter, just like you, right? I mean, it goes a long description, but the idea is it understands how Jennifer Aniston speaks, and it's already pre-trained into an LLM, right? So these are all powerful cases. So this is another case, like Chanel's, she's a Chanel's model, right? But then we took another lady who works there and generated her in the exact same model, the exact same Chanel jacket, right? So you can do all kinds of interesting capabilities with it. And of course, as you know, the holy grail is generating code, right? Because tomorrow when you go into a world, very few of you will write code. You will be like kind of, architects of software. Software itself can actually write itself, right? So this is an example where in our interplay platform, we taught the LLM to actually generate code, right? So today it's in an early primitive stage. What it means is it can generate functions. So you can say like, write me a function to convert a Fahrenheit into Celsius. It'll do it like that very accurately across every language, right? You could even do things like, generate me like one small web page or something, right? So simple things it can do, right? One of the things that we are embarked on is using LLMs and training them to do more complicated AI stuff. Like, if I say, generate me a gas pumping application or generate me a loyalty application that has 24 screens and 400 database tables, do it end to end, right? That LLMs cannot do. But we are embarking on that journey, training LLMs and fine-tuning LLMs, right? And in fact, we have folks in Sri Lanka working on technologies like that, right? And we are at an early stage, but there's a lot more to go. But that's where the future is going, right? The other thing about LLM is there are API-based LLMs like OpenAI and Google Bison. So if you're interacting with LLM, you just call an API. You don't actually put the LLM and train the LLM in your computer, in your GPU. Then there is Llama 2. Those are all like open source, right? Dolly, but all those things are open source. So as you are learning, learn both, right? So then, because the thing with the API one is you don't get to control them. You just work with them, and then OpenAI will take care of everything, right? But then you want to, as an engineer, you want to learn both, because in the open source world, you have better control. You can fine tune them, and I mean you can fine tune the others too, but this one you can fine tune them. You have better control. You can change parameters and everything, right? So now the benefits, I think, is like, the challenge with LLMs today is a lot of companies want to use this technology. Sometimes when I go and do demos like this, people are like, this is like magic. How did you do this, right? So large companies want to use this technology, but the biggest problem that they all have is that they don't want their private company data to go into ChatGPT. That's the biggest threat right now, right? So Microsoft and ChatGPT have been trying to tell them, well, it's we are protected and everything, but companies are still very skeptical. So one of the solutions is actually private LLM. So you can take something like a Llama 2, which is open source. You train it with the company data, and you can run it in the company's data centers. That is a big business, right? And in fact, we are involved in that. The other thing about some of these things is that the LLMs are still very slow, as I showed you. Their response times are very slow, right? How do you get LLMs faster? That's another big problem that you want to look at. And then the third one is basically the idea about you want to learn a lot on fine tuning and distilling and cleaning up LLMs to avoid hallucinations, right? Those are things that you want to really think about. So in LLMs today, if you're interacting with LLM, there are two main methods on how you train an LLM, right? The first is called the zero shot or the RAG, right? Retrieval augmentation generation, right? What it means is, say, like, let's say you are an insurance company. You have 50 PDFs that talks about your insurance policies, whatever. LLM is not trained on that, right? LLM is trained on internet data, right? Your data is private. So what you can do is you can take your data, put it on a vector database, and the vector database will basically create embeddings. Embeddings mean neural, conversions. And then what you do is you can hook up an LLM, and then what happens is when you make a query, automatically you will go and search the vector database that's matching the query based on what's already in the database. And then you find all the corresponding vectors, take them and pump it to an LLM. So as a context. So LLM knows that this is about some policy, this is about some bank, something, right? And then it'll give you a relevant response based on the data you get, right? The benefit of this approach is you don't need to fine tune or train an LLM. You can use the LLM out of the box. You are just augmenting it with your custom data that's already on a vector data. So that's the one. What's that? Yeah. Correct. Yeah, it's generating text. Yeah. It's still a vector stage. Yeah. It's this is an encoding. Yeah. Oh no, Interplay is basically our drag and drop platform. Right. I mean, this can be your own Python code. Instead of Interplay, this could be your Jupyter notebook. I mean, your code you wrote. Yeah. So it's actually running basically, it's taking the query, it's running a vector similarity search or a cosine search or one of those things, taking the data and invoking the LLM, right? Through a purely all done through a pure drag and drop capability, right? But this doesn't have to be Interplay. It could be your own Python code. Yeah, that could. Correct. So it has options about 5 different searches. You could run a cosine, you could run many different types of similarities. So one of the things that's also happening is nowadays you could do a vector type search, or you could do an elastic textual search too, because certain types of products, vector search actually returns too many irrelevant information because of the like if you have like, especially for like product, let's say you have an Eslon pipe, you are just, it's a Sri Lankan example. You have an Eslon pipe, and then the actual SKU number for that will be SLON-00014. The other one will be SLON-1400147. whatever. So then when you do a vector search, it'll kind of give you both, right? And it's hard to do refinement in a vector search. Then you can actually do elastic search, the traditional, because if you go to an e-commerce website and punch something, that's all elastic. Yeah. That's exactly, that's one of the problem. Yeah. In the vector search. And if you do like an elastic, you can avoid that because you can turn the weight parameters in an elastic based on how you're looking at it. So people are doing many different things. So for vector database, there are many databases out there. There is Pinecone, which is very popular, Face, which is from Facebook. So those are some of the stuff, right? And then the alternative method is you can actually fine tune the LLM. Right? So there is a process called fine tune. You can load in a JSON file, and then you can fine tune the LLM. And then LLM will get fine tuned, and then you can actually query the LLM directly. And then the third method is you teach the LLM a little bit, fine tune it, but then on top of it, you put a RAG, a vector database. So because one of the problems with LLM is you can only fine tuning is very expensive, right? If you begin to fine tune with lots and lots of data, then you are basically spending GPU time. But there are certain things you have to fine tune. If you have a lot of data, you cannot send all the data in a vector call because most LLMs have limited window sizes, right? The largest window today is 32 kilobytes, right? From Google Bison. I think Llama is 16, right? They all have different window sizes. So that's one of the problems that you have today in the industry, right? So this is our platform, Interplay, drag and drop. You can drag and drop and do all those things. I can give you a demo later, but in interest of time, like, as you are thinking about computer science and you guys are like embarking on research topics and stuff like that, these are some of the problems that are still there, right? One of the problems is multimodal LLM, because today the textual LLMs are not perfect, but they work really well, right? They can generate text and stuff like that. But there is very hard to understand charts and graphs and all those things. So if you give it a graph, a pie chart or like some chart, something like that, sometimes it'll hallucinate and give you random answers, right? So building multimodal LLM is a problem. There are several multimodal LLMs, but they are always doing images or pictures, right? So chart understanding, data understanding, because these are all practical cases, right? Imagine if you want to say this is a dog, it's not a big deal. I mean, there's so many applications that could do that, like Photoshop could do that, right? But then the idea is that if you feed in a chart and an executive want to ask questions about the chart to an LLM, that's a harder problem because LLMs can't really understand charts very well accurately, right? There are some Google libraries, but they still have failures, right? The other is end-to-end code generation, right? So it's a big problem because today LLMs can generate like functions, individual functions, and also all the code you have in LLM is only trained till 2021, right? Because ChatGPT ends in 2021, and the file database that creates all these things ends in 2021. So those are problems that you want to think about. Those are research problems you can tackle, right? The other is faster inference time, right? Optimizing LLMs and transformers on CPUs and to give quick response in real-time responses, right? Like 10 milliseconds, 5 millisecond responses. That's another interesting research type problem. The other thing that you want to look at is deep instruction following, right? So if you look at foundation models, on top of the foundation, there are two things, right? There are foundation models and there are instruct models. Foundation models has all the data. You give it a text, it'll complete the text for you, right? So the dog jumped open, right? So that's the completion, text completion, right? That's what the most foundation models do. But on top of the foundation models is what you have instruct model. So instruct model is where you can say, please write me a high school essay. Please write me an O-level social studies paper with Barack Bahu or whatever. That is instruction, right? That's a training on top of it. They've done reinforcement learning on top of an LLM and done that, right? But the problem is not all LLMs follow instructions the same way, right? Like if you take a set of instructions, there is a library that works with all the different LLMs. Our platform works with it as well, but there is an open source library. It's called LangChain, right? If you guys have heard of LangChain, LangChain. So if you use a LangChain, you can pretty much use any LLM underneath the LangChain. But the problem with all these LLMs is instructions that work on one LLM won't actually work on another LLM, right? So if you say do this and Google Bison will give one output and then the other one will like give you another output. They won't follow instructions exactly. So as time goes, there will be a lot more standardization. So that's an interesting research problem, right? Then the other problem, which I think is very important to our business, is actually large context windows, right? So today, the largest context window means when you query an LLM, the amount of information you can send it, right? So today the largest context window is 32K, right? So that's about 80 pages, right? 80 pages for documents is okay because that's a lot of information. You're not going to type 80 pages, a question that is worth 80 pages as a consumer. But if you are trying to make it generate code, 80 pages is nothing for a code. I mean, we have codes in Iterate that are millions of lines, right? So how do you actually feed that in one shot, right? That's a problem. So those are problems I think people are trying to tackle, right? The other is when you increase the context window, your processing becomes big, right? And LLM becomes slow because everything is a trade. It's a trade-off, right? How do you manage the trade-off, right? So this is what's really interesting, right? This goes back to my original point. It's not about just the hardware, right? Hardware is great, but I think the real power is in algorithms. You have to come up with innovative algorithms and methods to optimize and tune these things. So these are all interesting problems. Then the final is standardizing instructions. As you're interacting with LLM, every LLM has a different training way. Like if you were to fine tune a regular LLM, like a llama or something, it can take alpha instruction. This is defined by Stanford, right? Everybody has different instruction sets. So there is standardization that needs to come across. So these are all the things that you can look at LLM. So I just want to kind of share with you guys. So we're talking about the use cases. Why is AI powerful? What you are learning is like amazing. You can use it in industry, and the market is very big. You saw all the different use cases, and then I gave you demos of everything, and then we went into LLMs and we sort of talked about LLMs, right? And that kind of completes my session. Okay, that's fine. 5, 10, 11, 20. Any question? Yeah. Yeah. Very good question. Yeah. So that's one of the problems. It's kind of ironic, right? A neural network that runs on numbers can't handle numbers, right? But what's really interesting is there are many ways that people get around it, right? So one way to do it is like there are LLMs that they are doing specialized training at the transformer level to handle numbers better. But the more practical, simplest way is you actually use something called agent model. So what happens is like if you look at LangChain, they actually have a concept called agent and tools. So when you call an LLM actually can invoke a function, right? That function can do custom processing. So in LLM world, there is a concept called REACT, reason and act framework. So you can say like add 3 and 5. What do I need to do? So like if you look at LangChain, there is a tool called calculator or PAL calculator or whatever. So you can use a tool like that. So when you give numbers, so if a big LLM query has one small part of it is numbers, the LLM, the agent will run the whole query, come up with the answer, and the point where it needs to calculate the numbers, it'll actually invoke your tool. And it'll give the numbers as an input to your tool. And then the tool will do traditional math, just like not non-LLM math, right? That's the fastest way to get very accurate data. Like the one that you saw, that Bill's Burger, when we are calculating total price, that was not calculated by an LLM because it will give you random numbers and the company will lose profitability, right? Because it may give you the burger for $5 or whatever, right? But that's done by a tool which actually runs math calculations. Yeah. Which one? Yeah. I mean, those are interesting. Yeah, so one of the things is I think that's one of the biggest issues in the LLM world, right? So prompt injection is there, but then the way you can get around it is you have to control what goes in from an information security perspective, right? Like, I mean, you don't open up queries that are not pre-processed, right? So there are third-party companies like Bosch has a solution. They actually have an AI ML safety model analyzer that can analyze any queries that's coming in that could create vulnerability, right? And actually take away the sanity of the machine learning system. Right? And this is actually another growing area in security, right? Because if one of the problems is if you have lots of firewalls, right, and the information security folks, you guys know there's a lot of firewalls and IDS, IPS, and everything, right? They will track SQL injection commands and everything, but they don't have the ability to track a tainting of a machine learning system, right? You can just say Brian likes red shoes, right, or whatever, right? You feed the fake information constantly into a recommendation system. Next time I go, it's going to show me red lady shoes, right? Which is not true. But you can actually mess up with a lot of retailer systems. You can attack almost every retailer in America today because there is no guard in the front, right? And so companies are working on, because that will pass all the firewalls because that's legitimate query, right? It's an actual legitimate query. It's not a hacking query, right? But that's the thing that there are companies working on that. Bosch actually has an interesting solution in that space. I in fact have a deck that actually lists out all the different solutions. That's a space we looked at a while back, but we decided not to play there. But there are companies that do solutions. Yeah. Any more questions? Yeah. Okay, great question. Yeah. So there are two techniques, right? There actually, technically, there are three techniques. One is you can use RAG, which means you can scrape latest data and put it on a vector database and run a RAG against it, right? Depending on what your data is, right? But if you want to look at like internet data, which is, so you cannot hypothetically scrape the whole internet, that'll be cost prohibitive, right? So then you can't use RAG for that. The second method is basically called the stuff that I was talking about, the agent mechanism. So what happens is every LLM functions actually have an ability to call physical functions. So when you call an LLM will actually invoke a function saying, how do I process this? So you can actually write a query that will actually search Google. It's called SERP, S-E-R-P. There's an API called SERP, which actually goes and searches Google. So you can actually call SERP with that, take the response, and feed it back into the LLM, right? So even if you go to chat, if you have ChatGPT 4 or ChatGPT 4 Professional, there is actually a menu there. You can go and click saying, search the internet for this query, right? You can do that in ChatGPT 4. But if you're using like foundation models like Llama or whatever, you can use LangChain. In fact, if you go to LangChain's website, there is a example code that would do SERP for you, right? So that's kind of the way where you can add latest information with very little work. Yeah. Yeah, great question. Yeah. So people are actually doing this right now. Confidentially, Qualcomm is working on a system that can run on edge device. In fact, they're one of our partners. In fact, next 2 weeks, we are going to get a board that we can actually run LLMs on an edge device, right? So the challenge, I think, is it depends on what the application is, right? So if it's like the burger application I showed you, it's very hard to do because that requires real time and people don't have the patience, right? But if you are running it on a different application, like some kind of a document processing for a bank, anything that's more batch oriented, timing doesn't really matter. So you can run it on an edge device. There are people who claim they can do like 60 tokens a second on an edge device. I think it's hard to do, but I actually on this laptop, right? This laptop is running Apple's M2 silicon. So there is, if you go to the web and Google GGML, you will actually find basically it's a kind of a techie group. What they've done is they've taken all the LLMs that are out there and they've recompiled onto native silicons. So I can actually run here at about 15 tokens a second. So that's not fast enough for real-time apps, but it can do like a batch processing fairly well. Yeah. I have the same burger application that runs here. Yeah, but it'll take a while to respond. Yeah, but you can. Yeah, 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 yeah. You can do that. You can definitely do that. You can extract the learning and train another model, right? But the thing with the LLMs right now is folks are trying to build, trying to see how do you actually reduce its. There's a technique called quantization. So you take the LLM that's trained in the 16-bit and you quantize it to 4-bit. And in 4-bit, you can run it. So instead of actually trying to take the data and train into a smaller model, you take the LLM as is, but just quantize it to a smaller memory footprint and you can load it in here. So there are lots of libraries. There's a library called Bits and Bytes that can actually do a lot of the techniques for you. Any more questions? Okay. Oh, great question. Yeah. So that's a good one. In fact, that's a problem that we are working on as well, right? So the retail product recommendation traditionally, right? The old school way of doing recommendation uses a technique called collaborative filtering, right? You guys probably know, right? Basically it means that, Brian likes this and this, right? Udaya likes this and this, right? And let's say Siveswaran is a friend of Brian and Udaya, and Siveswaran, what will Siveswaran like? So Siveswaran could hypothetically like this and that, right? So that's kind of it's a collaborating filtering technique, right? But that's what most of the algorithms use at the very base. Nowadays, what they're doing is the world is get more complicated. So you are also taking transactional data, so as you're shopping, the data that you're looking at, they're using combining collaborative techniques. And then you're looking at their prior transaction records, pulling data from there. And then most of the time, most recommendation systems are using some form of a deep learning technique. So parts of it is some collaborative filters. The other is basically an MPL, right? A perceptron or something, a deep layer network that's actually responding to it, right? Based on prior observation. So that's how people are doing it. But everything that you did in a deep learning network can actually be put into an LLM, right? What's really interesting in the LLM world is it can also know, like, say, for example, if I looked at like for example, today in America, like people can buy third-party data about me, right? So not only when I'm shopping with this retailer, let's give a name, let's say Cargill, right? I'm shopping at Cargill, but Cargill can pay money to data company and buy data about my shopping somewhere else in another grocery, right, or another department store. So now with an LLM, because you've gone through all the data, because LLM knows almost every product, it can actually interpret my data from that store also automatically without me training. So LLMs can begin to do a little bit more intelligent way of doing it. So that's an interesting area where I think eventually you will see LLMs kind of combining traditional collaborative deep learning and then visual data interpretation, everything much better, right? The other thing with an LLM is the biggest problem in personalization and recommendation is the problem called cold start, right? Cold start means I'm a brand new person coming into the website. You don't know anything about me, right? So that's why, like a lot of recommendation systems, when you go in, you click on something, if they don't know you are going to that site the very first time, no cookie on you, it may initially give you some standard stuff to just keep you excited about the same category and things like that. So it's rule-based. But then the ML will kick in once you start shopping, right? So cold start might be solved by LLMs in a much better way. Yeah, because LLM has a lot of information. Yeah. Yeah. So the depending on the problem, if you're looking at recommendations specifically and personalization, the LLM already knows about a lot of products, a lot of pre-indexed information in LLM. That's the power of it, right? The other is you can also like scenarios where you could like sometimes what happens is like in the retail world and all, it's actually not, it's like when they first started using machine learning, the recommendation is called a black box recommendation. The deep learning network, it does the recommendation, right? Most retail, I don't know how here, but in the US, most merchandisers and most marketing people hate that because they are getting paid to tell you what people like, right? And then suddenly now you come and say, my engine will do it, right? And it's always a big barrier to adapt it, right? And then the other is marketing always runs all kinds of promotions, right? And then they'll create some campaign, and then suddenly you will see trends that are traditional. There's not enough data in a machine learning network to predict that trend, because this guy suddenly raised a campaign that is brand new, and the campaign went viral and everybody's going nuts, right? So in a scenario like that, in an LLM scenario, you can actually have an LLM agent. If it sees anomalies, it could get kicked in. And then, so you can build brown boxes well with an LLM. I think there are two advantages. One is a brown box capability. The other thing that will be really interesting is the LLM already knows a lot of information with all about a lot more training. A cold start will be better with an LLM. But on the other hand, the trade-off is that the LLM will be slow and more costly to run, right? Yeah. Yeah. Oh, great, great. Yeah. Then traditional NLP technique, that's what you do, right? You take a question and you send it to an intent analyzer, and based on the keywords and the structure, you identify the intent, and then you extract the entities, right? That's like if you look at scikit-learn and all those libraries, Spacey, right? That's what they do. That's a traditional NLP analysis, right? In the LLM world, you don't do that. You control it via prompt. You give it a system prompt, right? There are two ways to do it. One way to do it is like a pure LLM method, where you give it a system prompt and say, you are a helpful assistant who is running in a drive-through, only answer questions about a drive-through. A typical sequence of your experience will look like you greet the customer will order the burgers, and it'll order the drink, blah, blah, blah. Just define the sequence. LLM will take over. And then for doing the math, you just say, for running math, run the PAL math module or whatever, right? So that's the automatic LLM takeover from beginning to end, right? So the other method is a hybrid method, where we can do is you can take the text data, you can tell the LLM, based on this input, here are, if the customer says these things, means this intent. If the customer says these things, means this intent. If the customer says these things, means this intent. And you can actually use an LLM to build an intent identifier model, right? And you can build a traditional chatbot with the customer comes in, send greeting, ask intent, find the intent. If the intent is booking an event, run the booking event intent. Like you can keep on building that way. So you can do a hybrid model, or you can just give control fully over to the LLM. Yeah, correct. Yeah. So even in the full control system, you can do database details. So what you do is you can just simply put in LLM has two queries, right? A system prompt and a user prompt. In the user prompt, you say if this type of question, if this is what the answer is, format the response as : right? Ask what is your name? Please format customers respond as first name : last name : and that you can actually track that using a parser, right? And then you can just go look at the database and come back with the response, right? Because you can control each LLM request, you can control, right? You're going back and forth, right? Yeah. No, because you can your database details, you can just simply do a traditional SQL query, right? Because you are looking for known products and known things, right? Depending on what you're trying to do, right? Let's say you want to. I'll give you an. In fact, we did a similar example like this for a customer, right? So they wanted to interact with they're basically a luxury brand, and they want to build an event. So say you have, so if you're a very rich guy, you want to take your daughter and have a party in the retail store. Like, Americans are crazy, so they do all these things, right? So if you can go to this retailer's private event chatbot and say, I am having a party for my daughter's 18th birthday. Can I book your store? Right? And then the LLM can come in and then ask the question, okay, what is the date? What is the time? How many guests? Right? And it'll give you a quotation. This is how much it will cost. But that intent of looking at the today's price and the availability, checking the date, all that stuff is pulled from a database, right? So the way that the application is written is, there is a system prompt that says, this is what the application does. LLM kicks in, greets the person, takes the query, and then we wrote an LLM-based intent analyzer to say, what is the customer meaning? So it'll say, oh, the customer is actually meaning at this given time to book a birthday party for her daughter. Okay, great. If that's the case, if the birthday party is the intent, ask the date. Then it'll kick in and ask the date. Then the date will get formatted back and come in as actual key value queries. And then you can go to a database and query and make sure to check for that date if there's an appointment available, right? So you can mix like traditional programming with an LLM queries. LLM is fairly flexible with that. Yeah. Okay, awesome. Yeah, they can always email it to me. Yeah, thank you.
Because it turned out to be far interesting.
Okay.
Really got inspired and not learn. Like, I mean, you kind of gave a good review of a lot of libraries. And also gave really I just have a couple of the demo.
Yeah, it's for our so our company is growing, so they're getting all these sales guys. So I created a demo, he created a demo sheet to train all of them. Yeah, I can share that with you if you want to take a look at it. Yeah, yeah.
Appreciate it. And again, thank you so much.
Okay, thank you. Appreciate it. Yeah. Yeah, awesome. I like to take a picture with you. Yeah, let's take a picture. Yeah, that'll be fun. How do you want to do it? Oh, let's do that.